glad I pointed that observation out.
Cool. All right, so other questions?
Why is it so dark?
Because the lights are off. But it's also light, as you can see. All right, so let's play with trees. So we're going to do some tree balancing. So I have copies of these tree balancing adjustments, these rotations to make. So I'm going to have you go to the board in groups. In general, when we're doing board work, if you find a marker that's like really dead, just throw it out. And if you're out of markers, let me know. I'll grab some fresh ones. Okay, so don't struggle with dry markers. So here's what we're going to do. I'm going to have you build a tree, one number at a time. So you're going to want to insert this number into a tree, and you're going to want to work kind of neatly. Okay, so we're going to start off, and the first number you're going to insert is 100. So you're going to draw a tree that just consists of 100. Okay, so you're going to insert your number into the tree, and if there's stuff in the tree, you're going to start at the root, you're going to move down until you get to a leaf, you're going to put your number there. Okay, and then you're going to calculate balance factors. And what I'd like you to do is, next to each node in parentheses, write down what the balance factor is for that node. And we're going to talk about balance factors again in a second. So calculate the balance factor, and then if it's unbalanced, identify what case you're in. So how do you know if it's unbalanced? You insert a node, you calculate the balance factor from that node up to the root. Okay? And as you're going up, if you encounter a 2 or a -2, right there you know your tree is unbalanced. And you look at your 4 cases. If you encountered a 2 and the node after that was a -1, it's this case. If it's a 2 and it's a 1 or a 0, it's that case, -2, -2. So identify which case, and then apply the rotation, or rotations, according to this picture. Okay, so 3 lessons from the previous section. 1, you really want to write down very clearly what the balance factor is next to each node. Okay, and after we're done with this, after you've finished adjusting your tree and you've got your nice balanced tree, redraw your tree somewhere. Okay, and if I've looked at it and everything's fine, you can get rid of your old work. So you're just starting with a new tree, and then we're going to add 1 node to that and repeat this. Okay, second thing, balance factor is a function of each node. So if you have a tree and it looks like this, and there's stuff going on down here, and you want to find the balance factor of this node. Okay, here's what you do. Look at the left subtree, look at the right subtree of this node, which means none of this stuff matters. Okay, when you're finding the balance factor of a node, all that matters are the 2 subtrees of that node. So take the height of this left subtree, take the height of the right subtree, and subtract. Okay, it's really easy once you know how to do it. Take the height of the left, take the height of the right, subtract height of the left minus height of the right. That gives you the balance factor. How do you find the balance factor of this node? Here's the left subtree, there's the right subtree. Take the height of this minus the height of that. Bless you. Okay, and try to avoid shortcuts, because you'll see things that make you think you can take the balance factor and subtract the balance factor or something. It's always height of the left minus height of the right. Okay, and I'll put some possibly useful reminders up here. So balance factor. Balance factor of a node n equals the height of n left minus the height of n right. The height of a null tree is what? -1. The height of a single node is 0. The height of a tree like this is the same as the height of a tree like this, which is the same as the height of a tree like this, which is 1. Okay, and so on. So, specific example. Right? Balance factor of this node. Well, the easiest way to do this is just count. How many things do I have in the left tree? 1, 2, 3, 4, 5. How many do I have in the right? 1. 5 minus 1 equals 4. It's a bit of a cheat because the height of this tree is not 1. The height of this tree is actually 0. And the height of this tree is not 5. It's actually 4. But for a quick order, just count, how many levels you have on each side. And the difference will be the balance factor. So what's the balance factor of this node?
3.
3, right? 1, 2, 3, 4 minus 1. That's 3. And how about this node?
That's 3.
Yeah, that's still 3 because we got 3 on the left, we got nothing on the right. And how about this node?
2.
-2, right? 0 minus 2. And this one, right? And a single node, 0. Everybody got that? Okay, so you're going to want to find balance factors. Write them in next to each one. Okay, one more thing. Suppose we inserted a node, and this was what the balance factors looked like, right? We just inserted this node, balance factor is 0, balance factor 1, balance factor -2. As soon as you hit a plus or -2, you don't need to go any further up. Okay, so you can start from the node you insert. Everything we do, all of these rotations and stuff are going to happen right here. We're not going to modify anything above this node. So when we're done with all of our rotations, all of this is going to look exactly like it does now. But this part down here, which could have other stuff hanging on it and coming off in all kinds of directions, all of that's subject to change. We're going to change it by using these kinds of modifications. Well, when we're done and we've got this balanced version of this, we're just going to glom it right here on the left of this node. Everything else stays the same. Making sense? Okay, so go up to the board, find groups to work with. I'm going to put these over here. We got a few pink ones left if you're into Valentine's Day. Grab those. I'm going to stop this recording because the earlier class has an hour of background noise.